Today we are going to talk about three very important drugs, especially their mechanism of action. The drugs which I have chosen to discuss today is mechanism of action for clindamycin, erythromycin and chloramphenicol. I will explain that why I have chosen these three drugs together as a group to teach you their mechanism of action, what are the similarities in their mechanism of action, what are the very fine differences in the mechanism of action of clindamycin, erythromycin and chloramphenicol, and we will also talk about clinical correlates which are relevant with the mechanism of action, right? For example, we will talk about that if you clearly understand the mechanism of action, then you should be able to understand how these drugs competitively inhibit each other and why these three drugs are not combined in any clinical condition, why they reduce the effect of each other. We will also talk about a very special concept which is post-antibiotic effect related with clindamycin, and we will talk about a very special function of clindamycin, that how it not only it reduces bacterial proliferation or in higher dose it kills bacteria, but it also reduces production of toxins by staphylococci and streptococci, especially in toxic shock syndrome toxin and alpha toxins. How such toxins are managed by clindamycin. And in the end, very important thing, we will talk about the mechanism of resistance and mechanism of cross resistance in between these drugs, right? So when we start talking about, first of all, let's focus on mechanism of action. Now, the few things are common in these three drugs. All of them are, if you ask a regular doctor, what is the mechanism of action of clindamycin or macrolide? Erythromycin is one representative of macrolide group, right? If you ask a common doctor, what is the mechanism of action of clindamycin or erythromycin or chloramphenicol, he will tell you that these three drugs, they basically inhibit protein synthesis by bacteria, right? But we will delve into detail. We will talk about that how they inhibit the protein synthesis in bacteria, how they act on the ribosome, which subunit of the ribosome, and what is the exact molecular mechanism, how do these drugs work, and what are the similarities and what are the differences, right? Let's start with, first of all, very basic concept, that how bacteria produce proteins, how bacteria synthesize protein. A very brief review, a basic review. Once we are done with that, then on that basic concept we'll apply the action of these drugs. So as all of you know, that prokaryotic ribosomes, which are protein synthesis machines, molecular machines, prokaryotic ribosomes are slightly different from eukaryotic ribosomes. I mean, bacterial ribosomes, they are different than human ribosomes, and these drugs act on bacterial ribosomes and they do not act on human ribosome. And this is a clinical advantage we have, that actually this leads to selectivity and reduced chance of toxicity. Now let me draw a ribosome where these drugs are going to work. Let's start with ABC, very basic, that here is a ribosome. Let's suppose this is a bacteria, and in this bacteria, let's suppose this is a ribosome. Now ribosome has, functional ribosome has a small subunit and large subunit. Small subunit is called 30S unit and large subunit is called 50S subunit. Now, how these drugs work on these? I will remove this ribosome from here and magnify here, and then we will see normally how on these ribosomes what happens. This is 30S subunit, right? And it is about to make protein. Of course, all of you should know to synthesize the proteins, we should have messenger RNA. This is prokaryotic ribosomal 30S unit. So what will happen? First step will be that messenger RNA will be properly placed on 30S unit, right? And here is messenger RNA 5' and this is messenger RNA on, there is 5' and here is 3' of messenger RNA, and this is properly placed on 30S unit, right? Then once it is there, then these are the codons on messenger RNA, right? They are tripped. Now what will happen? The first transfer RNA which will come over here, this is okay, make it green. This is transfer RNA. The first transfer RNA which will come here, it will be carrying formyl methionine. It will be carrying formyl methionine, right? Formyl methionine, right? Carrying transfer RNA. Now, this will be attached here along with 30S ribosome plus messenger RNA plus transfer RNA with, what is this? Formyl methionine. And there will be few other helping proteins which are called initiation factors. They are called initiation factor number 1, 2 and 3. So initiation factor are also there. Now if these things are, four things are assembled, 30S ribosomal subunit, messenger RNA, transfer RNA with formyl methionine amino acid, and fourth thing is some initiation factor. If they are there, then this component will be called 30S initiation complex. What is it called? 30S initiation, yes, complex. So what is 30S initiation complex? It has four components: 30S ribosome, messenger RNA, yes, transfer RNA with plus, what is that? Formyl methionine and initiation factors. Now once 30S initiation complex is synthesized, then a bigger subunit of ribosome will bind with it, only then. And the bigger subunit, okay, I'm going to show it here. Right? Now this bigger subunit, this is called 50S subunit. What it is called? 50S subunit. When these things, this arrangement is there, 30S plus messenger RNA plus one transfer RNA with formyl methionine, right? And some along with that also 50S also has landed over there. Now this total complex is called functional ribosome, or more accurately 70S functional ribosome. Super accurately we'll call it 70S initiation complex. It is 70S initiation complex. Now in this initiation complex, there are some functional domains which are very important, right? What are those domains? Okay. Now functional domain, this area, okay, I will make it a slightly different color. This area which is mainly contributed by the 50s and slightly contributed by 30s, and this has one codon which is empty at initial stage. This is called A site. Right now, why this is called A site? Because it is going to accept the incoming transfer RNA with the appropriate codon anticodon matching and amino acid. Because it is going to accept in this area, it is going to accept what? New transfer RNA which is loaded with amino acid, which are usually called amino acyl transfer RNA. What are they called? Amino acyl transfer RNA. Now, amino acyl transfer RNA is supposed to come over here. This is their acceptor site. It means this is the place where they will, yes, what will happen? There they will funnel in here. They are funneling it here. What is this? Yes, this is amino acyl transfer RNA. So this will be coming at this site. That is why it is called either acceptor site, or it is also called, amino acyl transfer RNA site. Right? Then, if some cycles off, right? If some cycles off, which I will explain later, chain elongation have been done. If they have been done, then this must have some more amino acids here, right? Let's suppose 4 cycles of chain elongation have been done. How it is done, I will explain you. Just give me a few minutes. So we just see if this ribosome has worked for a while, and it is having a chain of 1, 2 and 3. These 3 amino acids. Now these 3 amino acids which are present on a transfer RNA, right, in this middle space, I will call it as in this middle functional domain. In this middle domain. Now this peptide chain is called newly formed peptide chain or oligopeptide chain, or very commonly called nascent peptide chain. The newly formed peptide chain, nascent peptide chain. And this transfer RNA now will be called peptidyl transfer RNA. This was amino acid which will come over here. Okay, I can show you that. Let's suppose one amino acid come over here, right? This is the amino acid new with its, of course, what is this? Transfer RNA. Now this amino acyl transfer RNA, what is this RNA? Peptidyl transfer RNA. Because it is having peptide chain here, so we call this domain, this functional part, P site. P for peptide, right? A for amino acyl or A for, there are 2 meaning everywhere. A site is for acceptor site, or A site is for, yes, amino acyl transfer RNA site. Here it is where that transfer RNA is present, where peptide chain is being formed, is present, right? Then we will call it P site or peptidyl site, or site for the peptidyl transfer RNA. Then there is third site, third functional domain, right? In this functional domain, in this area, if there is any transfer RNA is present over there, it will slip out. It will slip out. So this is outgoing. From here, it is slipping out. It is slipping out. Now this slipping out from this area, it means it is exiting from here. Amino acids are entering from here and exiting from here, right? This exit, so this site is called exit site. So up to now what we have learned, before I go into it, it gets a little more complex. I will tell you the basic, what we have learned, very simple thing. That when bacteria are going to start their protein synthesis, what they will do? They will activate their ribosomal machinery, right? Prokaryotic ribosomal machinery. What will happen? The first step will be they make 30S initiation complex, right? For that purpose, there will be 30S smaller subunit along with the messenger RNA oriented placed over it, and with that there will be first amino acid which is in bacteria. First amino acid is transfer RNA. Transfer RNA first amino acid brings with formyl methionine, and then after that, as codons determine, more and more amino acids will come and oligopeptide chain or nascent peptide chain will be formed here, right? How it is exactly formed, I'm going to explain in few minutes, right? Don't worry. Then I said now, actually, when formyl methionine is present, then 50S subunit come. So 30S initiation subunit has 4 component, 30S ribosome, messenger RNA, transfer RNA with formyl methionine plus initiation factor. Then 50S subunit come, right? When then 30 and 50S both are present, and what is this? One transfer RNA is present at P site with methionine only. Then we will say this is 70S functional ribosome or 70S initiation complex, right? Now I have shown you 3 functional areas. A site, all these areas mainly are present by within 50. Partially they are involving the 30S subunit. Now first is from where? What is this? Amino acids are coming, incoming amino acids, they come into A area. Then transfer RNA bringing new amino acid, they come into A area. Transfer RNA where oligopeptide or nascent peptide is present, or if it is not yet formed, then only methionine is present, formyl methionine is present, this is called P site. And then after that what happens, that another functional domain is here, and this domain is that if some transfer RNA comes over here, it will slip out of the system. So this is called E site or exit site, right? If you understand all this, this is the basic. Up to now we have just learned initiation. Now our drugs, clindamycin, erythromycin and chloramphenicol, they do not involve or interrupt the formation of initiation complexes, right? These 3 drugs do not up to now they have not done any interference. After this, after the initiation, there is another very important concept, that once the protein synthesis is initiated by formation of the 70S initiation complex, then how peptide chain is elongated, that is called elongation step, right? After initiation we will go to elongation steps. All these 3 drugs, clindamycin, macrolide group and chloramphenicol, all of them basically interrupt or disturb or inhibit or disrupt what? Elongation steps. Again, let me tell you what is happening. Up to now we have just made an initiation complex, right? And I explained how it is formed and what are the functional units. Now I am telling you that up to now during this activity, none of these drugs have made any significant action. After this ribosomal machinery will move towards elongation step. One by one, this ribosomal machinery will keep on adding amino acid and making a peptide chain. That is elongation step. That is where these drugs are attacking. Now I'm going to explain, right, clearly that what are the molecular events during elongation step normally, right? How prokaryotic ribosomes during formation of protein operate the elongation steps, how they keep on elongating the peptide chain, how they keep on adding the, yes, new incoming amino acids, because that is the step, early elongation steps. Those are the steps which are disrupted by clindamycin or erythromycin and chloramphenicol, right? So I will draw it here. Okay. Now you will tell me as I am drawing the diagram, what is this? 30S, very good. And okay, very rapidly, what was this? Yes, messenger RNA. Which end is here? 5 prime, 3 prime. Let's suppose it has been working for a while. So it has a, there is a, what is this here? Their codon, right? So and so forth. And what was the here? Yes, it was the transfer RNA which was having what? This was having recently formed polypeptide chain, right? So and so forth. And of course, meanwhile, this cannot go until 50S is not attached over there. This is 50S unit. Yes, very important thing. I told you there was some, what were these? What was this site? Acceptor site, right? What was this site? P site, yes, peptidyl site. And what was this site? Exit site, right? And from P site, from this site, there is something going, a tunnel is going outward. A special tunnel is going from this area outward, and from here the newly formed peptide chain will eventually exit. Newly formed peptide chain will enter into this tunnel and it will exit. This is called, what is it called? Exit tunnel. What is it called? Exit tunnel. Exit tunnel. Right? Now, this structure is there. We put it that already this transfer RNA is there and it has few amino acids already there. So this is peptidyl transfer RNA present on the P site. Now what will be incoming here? Another, yes, another what? Transfer RNA. Such transfer RNA where anticodon are complementary to codon of messenger RNA. And they are coming with what? A new yes, what is here? This has a new, what is it? Amino acid. Now, listen very carefully. What is happening? At A side, we have amino acyl transfer RNA. At P side, we have peptidyl transfer RNA, right? And if we have to elongate the chain, this is the chain formation, we have to elongate the chain, then this new amino acid which has come over here, this and this newly formed peptide chain amino acid, they should be connected with each other. They should be stitched together. They should be attached together. A peptide bond should be formed. That is the way to elongate the chain. So, let's suppose here is amino acid number, methionine has gone here now. Okay, methionine was circular. So, we'll make it, okay, let's put the methionine here, green. Now, this is, methionine was amino acid number 1, this is amino acid number 2, this is amino acid number 3, and 4th is the coming. Now, to elongate the chain, this ribosomal machinery must add incoming 4th amino acid with the 3rd amino acid of the nascent peptide chain. How it is done? We have to make a peptide bond in between two. How it is done? Now I will explain that. First of all, we have to determine that this reaction in which both of the peptide bond is formed, this reaction is this catalytic reaction, this enzymatic reaction. This is done by the 30S or 50S unit. Answer is 50S unit. Right? Now here let me explain. 30S unit is like a platform on which what is happening? Messenger RNA is stabilizing. And 50S unit, right, is having the catalytic activity. 50S unit within itself, somewhere, I will explain where, somewhere it has buried a special domain which has enzymatic activity. So, because 50S unit has one component or some group of domains which are capable of binding the upcoming amino acid with the previously formed chain, so we say this has enzymatic action. This catalytic activity is present in 30S or 50S? Yes? 50S. Now, where exactly in the 50S it is present? Let's come to the basic. Ribosomes are made of special RNA which is called ribosomal RNA. Ribosomal RNA are different. They are the structural component of ribosome. They are different from messenger RNA which is being translated. So, if I talk about, if I am saying that 50S subunit is going to do this enzymatic activity, then 50S unit is catalytic unit, and which part of the 50S unit is catalytic unit? To understand that, first of all, we should understand what are the structural component and functional components of the 50S unit. Actually, 50S unit is made of special RNA which is called ribosomal RNA. With that, it has some special proteins also which are called ribosomal protein. So, in short, we can say basically 30S and 50S both are made of ribosomal RNAs and ribosomal protein. Now, if we talk about, now I'm talking about that 50S unit, structural component is equal to ribosomal RNA, right, and proteins. Now, there is RNA within it which is ribosomal RNA, and there are proteins also arranged within the structure of 50S subunit. Now, some enzymatic activity is going on which will produce a bond in between these two. What do you think? This work will be done by ribosomal RNA, or this work will be done, enzymatic work will be done by proteins? Yes, Yes, gentlemen. I don't think you are so gentle. Why we call men gentlemen? It's very difficult to make the men gentle. Yes. You know, the latest movement of this feminism, they are trying to make the men domestic. Men are the last wild animal which is being domesticated with the massive effort of the very civilized, cultured, soft-hearted, beautiful woman. And I'm just, don't take it to your heart, right? It is just make the lecture light, right? So all of you should know that once you get married, the first thing your wife is thinking how to make this wild animal a domestic animal, right? But I will not go for that secrets how to do it, right? This is women's business. Let's come back. What I was talking, I forgot my lecture. What I was talking? You also forget. Oh my God. Everyone is thinking how not to be domesticated, right?
Which part of the ribosome is performing the...
Oh yes. I was saying, I've already told 50S subunit is basically having catalytic or enzymatic activity. And then I said 50S unit is made of some ribosomes and some proteins. Now, this is the ribosomal component of 50S subunit or proteinaceous protein component of 50S, which is going to act as an enzyme. Let me explain myself. Actually, most of the proteins, most of the people think it must be proteins because there is an enzyme. And as very good, brilliant doctors or medical students or paramedical students, we have learned that all enzymes are mainly proteins. All enzymes are mainly proteins. But here is a exception. You know, there is a ribosome present over here, special type of ribosome, ribosomal RNA, sorry. There is a special type of ribosomal RNA present in 50S unit. That special ribosomal RNA has the catalytic activity, has the enzymatic activity. This is very big exception because generally we say that all enzymes are proteins. But here is an enzyme which is RNA, ribosomal RNA. Let me tell you where is that. If you're looking for that, let me draw one more diagram. That here is your 30S subunit and here it is your 50S subunit. Now, here is that, where is that enzyme present? Actually, there is a very special type of ribosome present here. Okay, I will show here. It is over the A site and P site. And this ribosome is present over here. This ribosome is called 23S ribosomal RNA. There is a special ribosomal RNA present where? In 50S subunit. And this is called 23S ribosomal RNA. What is this? 23S ribosomal RNA, which is component of the 50S. Now, and of course it has some proteins around it, but the enzymatic function is not done by proteins, not done by protein. The enzymatic function is performed by 23S ribosomal RNA, which is present in what? 50S unit. Right? Now, again we come. If you are the person who is trying to look how elongation step occur, how one amino acid and second amino acid, these amino acids are catalytically what happen? Joined with each other. So, simple way we say this work is done by ribosome. One answer is you say ribosomes do it. If you are little more sharp, you will say 50S subunit of the ribosome. If one of you is more brilliant, he will say within the 50s unit into its lower portion,
23S.
right? There is a ribosomal RNA 23S, right? Now again, simple doctor will say ribosomes are doing chain elongation, right? Actually, this chain elongation step, I'm saying again and again, we are making a bond here. This bond formation process is part of enzymatic action which is called transpeptidation. What is it? Transpeptidation, right? Now, this transpeptidation process, if you ask a doctor, first doctor will say it is done in transpeptidation for chain elongation during the protein synthesis is done by ribosome. He is right. Then second doctor says it is ribosome, but to be more specific, it is 50S subunit. Then third doctor say, yes, it is ribosome, it is 50S subunit, but within the 50S subunit, there is a special, yes, ribosomal RNA 23S subunit. So you see how we are moving. We are moving, first we say ribosomes are doing chain elongation, then within the ribosome we say 50S subunit, within the 50S subunit we say, yes, 23S, right, ribosomal RNA, which is part of the 50S, right. Now this has the catalytic activity. It is responsible to bring these two amino acids in proper alignment, right. That is why this is present, this thing, I will make it, okay, I will make it like this. This is what?
23S
Ribosome. And it has one hand here and one hand here. And what it is doing? It is bringing them together closer and making their proper alignment so bond is formed, right. So what is this? What you will tell me? What is this thing? 23S ribosome present in 50S subunit, right. 23S ribosome, and it has two functional domain. Okay, just imagine I am the 23S ribosomal RNA, right, and this is my head and these are my two functional domain. In one domain I will grab this incoming amino acid, and in other domain I will grab amino acid from the newly formed peptide chain, and I will align them together, bring them together and help them to make a bond. So if I can do this, then it means this ribosome can be called ribozyme. This ribosomal RNA can be simply called ribozyme. Ribozyme, not enzyme. When someone says within the 50S subunit, 23S unit is there, which is doing an enzymatic function, so that can be called ribozyme. Now, because it is doing making a bond in between them, it does two-step function. One step is to make a bond. Now, this function is called, functionally, this is called, what is this? Peptidyl transferase function. Peptidyl transferase function, right. So this is our ribozyme, this is our 23S subunit, this is our Yes, what else is it? This is our ribozyme. Actually, it is our peptidyl transferase. How does it work? That it is present in the lower part of the 50s subunit, or that part of the 50s subunit which is near the, what is this? Near the those part where transfer RNA are present. Now, as you know, all amino acids have two ends. For example, this is an amino acid. It has two ends. One will be amino end and other will be carboxyl end. Right? So what will happen? That from this chain, the incoming amino acid, which is this one, its amino end and amino, and what is this? And peptide chain, this end carboxyl end. In between them, bond will be formed. Right? In them, peptide bond will be formed. Now, who has made this bond? 23S ribosome, or who has made ribozyme, or who has made peptidyl transferase, right? They one and the same thing. Now, once this bond is formed, immediately after that, another thing will happen. Now, our drugs are going to work on this area. As soon as this step is formed, bond is formed, what will happen? I will now make it here. This is 30S very rapidly. This is transfer RNA, and yes, here was your 50S unit. Here was your which part? A site, what? P site, E site, right? Here was your exit tunnel for peptide chain, right? Here was the transfer RNA at the P site having nascent chain, right? It was having the chain in which there were amino acid and there was also here and this. And we have said that within the 50S, here was this naughty man. What was this? 23S ribosome RNA, ribosomal RNA, and its two functional domain. This is right. They will attack A site and P site and make a connection in between that. This is what we have learned up to now. Once this connection is made, listen with your both ears. Once this connection is made, function of peptidyl transferase is not finished. It has to do one more function. It has to do one more function. You know what it has to do? It will detach. What is this? This nascent peptide chain detach from here and transfer it to newly, what is this? Newly arrived. So this chain will come over here. What were the components? One amino acid, then another amino acid, and then another amino acid. Now you see the peptide chain which was owned by transfer RNA which was present in P site. Peptide chain, this peptide chain which was owned by transfer RNA which was present in P site. First this our ribozyme made a peptide bond, right, between the only a nascent peptide chain, newly formed peptide chain, and the newly arrived amino acid. After making the bond, it is very cruel. Whole world is cruel, including the ribosomal function. What cruel thing it does, it makes a bond, and this transfer RNA was very happy at P site. Wow, one more amino acid. But this enzyme or ribozyme or 23S ribosome, it will pull the peptide chain away from this transfer RNA. And this previously formed peptide chain will be gifted to the or transferred to the newly arrived amino acid. Actually what happened, new amino acid came, pre-existing chain was attached with that, then pre-existing chain, pre-formed chain was detached from its own transfer RNA, from peptidyl transfer RNA, and chain was shifted to the transfer RNA which was present on at A site. So what will happen now at this situation? What will be the situation there? Let me explain. Once this step is done, okay, what I said, this was our new amino acid, and now this naughty, what was it? Ribozyme, he has done two things by its domains which work at A site and P site. What it has done, number one, the chain which was present over here, right, at the P site, one of the amino acid of this and amino acyl transfer RNA amino acid made a bond in between that chain and then transfer the chain from here to here. So now here is the previous amino acids, right? So it has two functions. Number one, if I am the 23th, if I am the 23S ribosomal unit of ribosomal RNA of 50S unit, if I am that, then these are two my domain. This domain is working on P area and this is working on A site, right? And I will bring those amino acid together. Here was what? Peptide chain, and here was new amino acid. I will bind them together, and after binding I will detach the chain from the P site transfer RNA and transfer this peptide chain to the new amino acid at the A site. You are understanding? So now situation will be like this, right? That A site is now having its amino acid which has also stolen away or received as a gift previously formed chain, right? Now, so this whole function, this transfer of this chain to that amino acid, right? This is the second part of transpeptidase reaction. So it means now we make it simple. What is transpeptidase reaction, right? Transpeptidase reaction during the protein formation is done by the 50S subunit. To be more accurately, within the 50S subunit, in case of bacteria, in 50S subunit, more specifically, there is 23S ribosomal RNA. This ribosomal RNA is also called ribozyme because it has enzymatic function, and right, this ribozyme is also called peptidyl transferase because it will take the previously formed peptide chain and transfer to the new amino acid, peptidyl transferase. But before the transfer, it has to make a peptide bond. So it does it. First, ribozyme will make a bond between the incoming incoming amino acid and amino acid of the peptide chain. First it make a bond and then detach this, right, and transfer this peptide chain to the new amino acid, right?
Yes, sir.
That is why we will call it peptidyl transferase. So here peptidyl transferase has done its function. Now some authorities call it translocation also, but there are two concepts of translocation. When we talk about the ribosomal translocation, translocation is of two types. Either there is peptide chain translocation. Peptide chain is, this chain of the peptide is translocated there. Peptide chain translocation. And other is, I will tell you within 2 minutes, that whole complex of, what is this? Ribosome, functional ribosome, moves towards the 3 end down one codon. That is called ribosomal translocation. Again, I know it's getting confusing. First, listen one thing. Up to now, for chain elongation, we have done what we have received. We have received a new transfer RNA at A site, minus L transfer RNA bringing new amino acid. Then the next step was peptidyl transfer RNA or ribozyme was activated and it made a bond between the nascent peptide chain and the new amino acid. Next it did that it transferred the preformed peptide chain, detached from transfer RNA on the P site and shift this chain to the new amino acid which is which was attached with the transfer RNA at A site, right? So peptide chain was transferred. So we say, what we call it, that this function was peptidyl transferase, right? Peptidyl transferase. But actually, somewhere in literature, you may come across that some authorities say this is peptide translocation. Yes, peptide translocation it can be called, but don't confuse peptide translocation with ribosomal translocation, which I will teach you in few minutes. Up to now, everything clear? Do you have any question? No question. Okay. Now we'll move further because yet elongation is not completed. I want to show that what will happen after this. Why I'm so much stressing on that how peptide bond is formed and how peptidyl transferase work, because many of our antibiotics work on peptidyl transferase, or we can say they work on 23S ribosomal RNA, or we can say they work on ribozyme. Actually, clindamycin, erythromycin, chloramphenicol, all of them work on chain elongation process. Let's come back very rapidly. Yes, what is this drawn? 30S. What is it? 50S. Yes. What was this area? A. This was P. This was E. Right? And what previously we have done, we were having an transfer RNA here. Of course, it is not possible without messenger RNA. Right, now we had one transfer RNA over here and we had one transfer RNA at A site, and previously we discussed that here was our special enzyme. What was that? Peptidyl transferase, having two domains, two active domains, and whatever peptide chain is present over here, right, whatever, how many amino acids, right, it makes a bond, this with the new amino acid, and after making a bond, it transfers this peptide to the new area, and when it transfers it to the new area, then the next, yes, you have any question?
No, sir.
Okay, I will just make one more. Now I am going fast because I hope you are already understanding. Yes, what was this transfer RNA at which site? P site, and this transfer RNA at A site. And due to the action of, what was this? Peptidyl transfer RNA. Due to this action, the transpeptidation has been done. Due to that transpeptidation, new amino acid is also having previously, yes. Now, next step will occur. You know what will happen? Actually, just after that, once transpeptidation process is completed, after that, ribosome will move along the, what is this? Along the messenger RNA, right? It will move down along the messenger RNA towards its 3' end. Ribosome will move. And if ribosome will move, now it will, previously these were the codons, right? Now it will move, suppose it will move to this codon. I will highlight this codon like this. Now what will happen? 50S and 30S, once transpeptidation is done, right? And P site is not having any amino acid, right? This ribosome will slip. It will move towards 3' end. Just how much it will move? It will just move down one codon, or it will move down 3 nucleotide, because 3 nucleotide make one codon. So what will happen? When it will move like this, the new situation will be after the movement, new situation will be, yes, when it will move down, then new codon will come over here. You understand? And this codon, which was having the transfer RNA with elongating chain, that will come when ribosome will move a little, one step ahead. Then what will happen? This transfer RNA, which was present at which site? P site, right? This will shift to the E site. So this one will shift over here, this transfer RNA, right? Actually, it is not needed now. It has, this was the transfer RNA, which was having originally the chain. New transfer RNA came with the new amino acid, then there was bond formed, then peptide was detached, and this peptide chain went there. Now this become without amino acid, or we say uncharged or unloaded transfer RNA. So when this will move one step down, so naturally this will slip to this side, and newly formed peptide, this will slip to this side and that will slip to this side. So what will happen? That transfer RNA, which has lost its peptide chain, which was present originally at P site, when ribosome will move one step down, right, then this will find itself at E site. It will find itself at E site, so it is going to be expelled. It is no more needed. And what was this? This was A site where amino acid has already received a short chain of amino acid due to transpeptidation. This transfer RNA along with its newly acquired chain will find itself in which area? P site. Yes. So this has become to E site, this has become to E site, and this has become to P site. And now A site becomes empty. Now A site is empty. Codon is there, but transfer RNA is not there. So what should happen? What should happen? Now a new transfer RNA must come with a new amino acid. So this is the new amino acid. If this codon and anticodon, they are complementary to each other, then this will sit over here and there will be arrival of what? New transfer RNA. New which transfer RNA? Amino acyl transfer RNA, right? And again the same cycle will be repeated. What will happen? This step, first of all, when all this rearrangement occur, we say whole ribosome has translocated one codon down the messenger RNA towards its 3' end, right? So there are two translocation. One translocation is translocation of peptide chain, and other, this is peptidyl transferase action. What is this? Peptidyl transferase action. And other is when ribosomes moves one step down the 3' end, then we say ribosomal translocation, right? So when I say peptidyl translocation, what I'm talking about? I'm talking about transpeptidation. I'm talking about transpeptidase reaction, right? So to finish the confusion, it's better that this section, right, should be called simply transpeptidation. An action after the transpeptidation, when ribosome moves further down, that should be called simply translocation. Is that right? Now what has really happened? Now cycle is again going to be repeated. This will come very happy, and it should have one domain here, one domain here, and it should help a bond in between them, and then peptide chain should be translocated here. When peptide chain is transferred to A site, what will happen then? Again a ribosome will move one codon down. In this way, this chain will be elongated, right? So this cycle of, now listen, there is a cycle: arrival of the amino acyl transfer RNA, then peptide formation between the new amino acid and the nascent peptide chain, and then transfer of peptide chain to the new amino acid, and after that translocation, and then arrival of, again the whole cycle repeat. So this cycle keeps on repeating until ribosomes keep on moving and they reach up to termination codon, right? Stop codon. So when they reach to termination codon, when termination codon come here, then no more comes any transfer RNA. Then termination factors come and they help the peptide chain to go out through the peptide tunnel, and they help, the termination factors help the ribosomal machinery to disassemble. 30S will be separated and 50S will be separated. So this is how formation of protein synthesis occur and elongation. Now we have to talk about basically clindamycin, erythromycin and chloramphenicol. They work on peptidyl transferase, or they work on ribosome, or they work on 23S ribosomal RNA, right? How they work, all of them work over this, but they work slightly differently. And there, if you that how they work and what are the slight differences in their action, in elongation process, and how it translates into different clinical effects, right? How it translates into these clinical effects, that we'll be discussing in the next lecture after the break.
Yes, sir.
Thank you very much.